Good afternoon. In this video we're going to set up logic cell game number 2, and we're going to create a new work cell, handling pro, call it what it is. Pick your version and pick your tooling. So we're going to go to the 3-jaw if it's not already there. So we're going to go to grippers, find the 3-jaw chuck, and we're going to use the R2000 IC 165F. And we're going to continue next, and then finish. And then we're going to allow this teach pendant to update. So the question about flange type, we're going to do standard. So we're going to go 1, enter, and allow the cell to initialize. Now that the cell is initialized, let's start putting together the cell, and this cell is the same between all the different logic games. So the first thing we're going to do is we're going to add a plate underneath our robot. So we're going to move our robot up 500 millimeters. So we bring her up, and we're going Z 500. So we're now 500 off the ground, and we're going to add a robot table to this. So I'm going to go to cell, and we're going to go to obstacle, CAD library, and we're going to go to robot bases, and we're going to use the first one here, which is the 2907904 X3777. We're going to bring it down so that the Z is 0. And we're also going to change the size of this as well. So the size in the X is going to be 1.25. The Y is going to be 1.125. And then the Z is going to be 1. So when I hit apply, it now should fit perfectly on the base with a little bit of extra all the way around. So now that we have this, we're going to then lock our location and hit OK. Next, let's add the table. So we're going to go cell, and we're going to add fixture, and then we're going to go CAD library, and we're going to find the tables, and we're going to find the table with legs, and we're going to modify the size so that the X scale is going to be 1.25, the Y is going to remain 1, and the Z is going to be 2. Then the X is going to be 1600, the Y is going to be 0, Z is going to be 800, the W is going to be 90, the P is going to be 0, and then the R is going to be 90 as well. And when I hit apply, it should be directly in front. And I'm going to lock the location of this, hit OK. Next thing we're going to do is create the part. So we're going to go cell, part, and we're going to create a simple cylinder, and we're going to change the size from diameter to 50 and 100, and we're going to have a 2 kilogram mass for this. Okay, so now that we have the main cell set up, let's now set up our main U tool. So let's double click our 3-jaw chuck. Let's go to U tool, and let's just make sure that the triad is the correct direction, whereas the Z plus is up, Y is to the right, and then X is forward. Let's go edit tool, and let's just double check everything. Looks like everything is good, so we're at 415 Z, W 180. So if you need to modify that, you can use current triad location and modify these numbers. So let's hit apply on that. Let's go to parts, and we're going to add a part. Let's hit apply on that so we can see our part. Now we need to modify the rotation of this. So we're going to edit part difference, 415, and the W needs to change to, we want to modify so that the triads are the correct direction. Right now it's downwards, so we need to modify this to -90. And now we have our triad Y positive. And we just want to make sure that these are matching when we add it to the tabletop games scenario. So the Z is going to be to the left, the X is facing forward, and the Y is facing up. So let's hit apply on this. Let's hit OK. And now we're going to set up the actual jaws. So we'll hit the plus next to the 3-jaw gripper. And let's double click jaw number 1. And we want to make sure that all these match. So it should be 0, 0, 0, 0, negative 90, 0, and those should be all good. We're going to go on the Z-axis. Let's go to the motion. We're going to switch this to device in and out, linear motion, and we're going to go speed of 1000, both forward and back. It's going to be a very quick speed, and we're going to be using robot controller number 1, and we're going to use digital 1 for our opening and closing. So one's going to be on, one's going to be off. So when it's on, it's going to be at our open position, and closed is going to be at 20. And we can test that to see what that looks like. So off means it's open, on means it's closed. So if I go test, you can see it move open, and then if I go up here and go test, you'll see it go closed. So the open and closed. And then for the outputs, we only need to put this on one of the jaws because they're going to go at the same exact speed. So this is going to be digital input number 1, and this is going to be digital input number 2. And both of them are going to be on, so location is going to be 0 and location is going to be 20. So again, we only need to do this for one of the jaws. So I do it for the first one, and you don't have to do it for any of the other ones. So I'm going to hit apply and OK, and let's set up the second and third jaw. So the same exact thing, go to the motion, and we're going to do a device in and out, linear motion, speed of 1000 millimeters per second, 1000 millimeters per second. Output device is going to be still the digital controller number 1, so that they all turn on and go at the same time when we call for it. There we go. So now that is open. Now we're going to go to the next one. Remember, we do not need to put an input or an output. Let's go to jaw number 3, and we're going to go device in and out, linear, speed of 1000. Robot controller number 1, and then digital 1, digital 1. One's going to be on, one's going to be off. Off is going to be at 20. We do not need to put an output. So let's hit OK, and everything is now set up for our jaws opening and closing. Let's create the simulation program for the gripper open and close. So let's go to Teach, Add Simulation Program, and we're going to call this one Gripper Open. And when the gripper is open, we're going to utilize digital output number 1, and that's going to mean we're going to be off. So we're going to wait for digital input 2 to be on. So digital 1 off, wait until digital 2. So we're going to hit play on that. Should remain open. Then let's start the close process. So we're going to go Teach, Add Simulation Program, and we're going to go gripper closed. Hit OK. And we're going to go digital output number 1 to be on, and we're going to wait for digital 1 to be on. And when I run this program, it should close. There we go. So now we have our opening and close program to call. Let's turn on Teach Pendant and set up some position registers. So I'm going to go to Data, Type, Position Registers, and we're going to go, first one is going to be Home Position. Next one is going to be Safe Position. Third one is going to be Game 1, so this will be the logic cell number 1. Starting point. Game 1 end. Then we have Game 2 starting point. So I have my start and end for all 3 games because again, this cell is the same startup. It's just the board is just a little bit different. Then for position register number 10, we're going to do our tool offset. And then going down to number 12, this is going to be our game offset. So this is going to be game 1 X, Y offset, or you can just call it offset. So now we have all our position registers set up. So let's just record all these. So I'm just go shift record, shift record, shift record. And right now they're all going to be the same until we actually set up everything. So now I'm going to actually go into the home position. So I'm going to go to position, and our home position is going to be 159.2, 0, 671, 0, 0, 0. So this is our home position here. For our safe position is going to be 0, 831, we'll just go 832, 356, 0, 0, and then negative 90. And if you want, you could just go move 2, which will move to our safe position. Let's go to our tool offset. So go to position, tool offset is going to be 0, 0, 0, 0, 0, 0, and then we're also going to change the Z tool offset to 200. And let's go to the game 1 and game 2 offsets. Let's go to position, and let's make that zeros down the board. Let's go to game 2 position, zeros down the board. And game 3 position, zeros down the board. Go to type. Let's go to normal data registers, and here we're going to type in, the first one is going to be our speed. Then we're going to have our column counter. Then our row counter. And if we need to, counter number 1. And counter 2. And speed, and we just set to 2000 right away. And the rest will be utilized inside the actual program, so we can remain as 0. So now this is where the two cells are going to kind of start parting. So in logic game number 2, logic game number 3, this is where the board is going to be different, and the position registers for the start and end is going to be different as well, along with the programming. Let's go find the parts on the web. So let's go to the YouTube page under the About. Find the one that says Cell Setup, Logic Game 2 and 3. Will bring you to this page right here. And we want to download our part files. This also has setup folders as well with the programs. So I'm going to grab these and I'm going to download them all. Once I downloaded the folder, I placed and unzipped the folder into the work cell on my actual documents. So I have everything inside here, including all the parts and pictures inside this work cell. So here's my logic game number 2. So now when we bring in our parts, we're able to easily move them and export everything really easily. So let's go to cell, let's add fixture, and let's go to single CAD file. And we're going to go to the folder where your actual cell is being created inside the folder that we downloaded, and we are going to download part 2.1. Hit open, and here are going to be the coordinates for that: 1600, negative 900, 800, 90, 0, 90. And when we hit apply, we will then have our part in the correct area and the correct direction. So I'm going to lock the location. I'm going to hit OK. I'm going to bring in the second part then. So we're going to go Cell, Add Fixture, Single CAD File, and Part 2.2. Hit Open. And then we're going to put in the same coordinates for this as well. 1600, negative 900, 800, 90, 0, 90. And now we have our part in the correct area. We're going to lock locations and values. Now let's set up the parts and simulation. So let's go to parts, and I'm in part 2.2, hit part, apply, and then we need to move that part to the correct area. So we're going to edit part offset, and the X is going to be 1000, Y is going to be 40, Z is going to be 200, and then the WPR is good because the Y is going straight up, X is going to the right, and Z is going forward. So we're going to hit apply, and this is going to be pickup area, so this is going to be visible at runtime. Let's go to simulation, and we're going to click this part. This is going to be where it's going to be picked up. So let's go uncheck place, and we're going to pick up, say every 2 seconds we're going to have one be created. We're going to hit OK, and now our pickup area is all good. So let's now move to the part 2.1. So let's double click 2.1, and let's go to parts. And here's our part. The first thing we need to do is move it into place. So let's click our part. We're going to hit apply, and we're going to edit the part offset, and this is going to be 600, 40, negative 200, and it should be in the lower left corner. Then we are going to go to simulate, and we're going to click part, and this is going to be allowed to place. So we uncheck the picked and then the place, and we're going to destroy after this amount of time. So that means it's going to remain there after we place it until we're done with the cell. Let's go to parts then. This will not be visible at runtime, so let's uncheck visible at runtime for our first part, and then we're going to array this. So let's go add, and we are going to do an array of 5, 1, 5. So 5 in the X, 5 in the Z, because it depends on the triad here. So X this direction, Z is this direction. We're going to have a spacing of 100. Y doesn't really matter, so I just put 100 anyways because we only have one. So that means it's going to create just a single row for our array. Let's hit OK, and then we will have the total array. And here's where you now need to go through and delete the ones we do not need. So for row 1, we're going to need all 5. So row 1, all 5. Row 2, we're going to have everything except the last one. So right here, 2.15, we're going to delete. We're going to uncheck the 2.5, and we're going to go to row number 3, in which we're going to do the last 2. So uncheck the last 2. And then row number 4, we're going to uncheck the last 3. And then the row number 5, we're going to uncheck the last 4, so you should only have 1 left over. So it should go 1, 2, 3, 4, 5, all the way down. So then when I hit apply, we will be left with just the angled rows. And because we had these all set up before we arrayed it, you'll see all of these are invisible at runtime. Same thing with the simulation. All these simulations are going to be destroyed after 999. So these are all good. So we're going to hit OK. And the last thing we're going to do for this cell before we start looking at the pictures for the actual program is teach the position registers for the start and end. So let's go to data, and let's go to the position register, and we're going to go here where it says game to start. So we're going to start right here. So I'm going to double click this piece right here, go to parts, and then move to, and it'll move to this position. So here's game to start. So we go shift record. So now that position is now recorded. Close out of here. Double click this one, and we're going to move part 1, 1. So we're going to go move to. There's the end part. So I go to position register number 6, and we're going to go shift record. So now those 2 points are recorded. So we have the start and end point. Hit OK. And then we need to start programming. So we'll create the 2 simulation programs for pickup and close. So we're going to go to Teach, Add Simulation Program. And this simulation program is going to be, since we're at the end here, we're going to call it End Drop Off Game 2. So End Drop Off Game 2. Hit OK. And this is going to be our drop off. So we're going to instructions, we're going to drop, and we're going to drop the part, and there's only one area we can drop it, which is logic piece 2.1. And make sure that the part says asterisk in there. So it'll default to asterisk, but just double check to make sure that it is. So then we're good on that one. So let's then go Teach, Add Simulation Program, and this one is going to be the Start Pickup area. So Start Pick. Hit OK. And this is going to be our pickup. So let's go Instruction, go Pickup, and we're going to pick up the part from logic piece number 22 and with the 3-jaw chuck. Okay, so now we have all the simulation programs, and now you have to create the Teach Pendant programs by going Select and then Create, and here are the Teach Pendant programs. So inside that folder, you'll be able to see each of the different programs. So the Game 2 part pickup, you're going to create with the U-frame number 1, U-tool number 1, U-frame 0, and then U-tool number 1. And then you're going to go to the position register with the tool offset. Then you're going to pick up and then move to the save position. And then here's our part place program, much like the pickup program, but instead of the pickup gripper being closed and the drop-off program, we're going to have our gripper open and drop-off program number 2. So the simulation programs. So this is a simulation program. So this is Game 2 part place. Then you will need to create the answer. So here is the example for the answer. So we have Game 2 answer. And again, this is not the only way of doing things. There's other ways of creating the program. This is the way that I did it. Doesn't mean it's the only way of creating. And that's the Game 2 answer. So once you're done program, then you should have the entire program picking and placing where it needs to be. So think about what you need to do for the logic in order to pick and place, subtracting and adding as you go. And that is logic game number 2. Good luck.